Hello everyone, this is Mrs. Aparna More, Assistant Professor from PES Modern College of Engineering, Pune. Today we will be seeing phase lock loop. So, phase lock loop, we say it as PLL. So what is PLL? We will see the contents about it, the block diagram, the characteristics, phase detectors, then the details of PLL IC 565 and its application. So, we start with the block diagram. Block diagram consists of before going for the block diagram, we will see what is phase lock loop. It is a circuit that produces output signal which is synchronized with the input signal in terms of phase and frequency. So, the output and input signal of the circuit is synchronized with respect to the frequency and phase. The applications of PLL are they are used in frequency multiplier, frequency demodulation, frequency synthesizer, satellite communication system, frequency shift keying decoders. The block diagram. So this is the block diagram. The basic blocks of PLL are the phase detector. So we have the first block, that is the phase detector, through which the input is given. The parameters of the input signal are phase and frequency and voltage. Then the other input to the phase detector is coming from the feedback path. The output of phase detector is going to the low pass filter. The low pass filter output will give the signal, that is the low pass filter will pass the low frequency signals and it will filter the high frequency signal and it will give it to the error amplifier. The output of error amplifier, which is VC, is given to the voltage control oscillator. So we will see in detail what is the details of the block diagram. The phase detector compares input frequency Fin with the feedback frequency Fo. Output of phase detector is proportional to phase difference between Fin and Fo. That is, we will have at the output of phase detector two values, Fin minus Fo and Fin plus Fo, which is a DC voltage. Now both the signals are given to the low pass filter. Out of that, only Fin minus Fo is passed. As it is a low pass filter, the high frequency signal is removed. This DC input signal is given to the voltage control oscillator. The filter helps in establishing dynamic characteristics of the PLL circuit. We will see what are the dynamic characteristics later. The output frequency of VCO is directly proportional to the input DC level. So, VCO frequency is compared with the input frequency and adjusted until both the frequencies, input and output, are matched. So, the PLL goes through three states: free running, capture mode and phase lock mode. So, what is free running state? Before the input is applied, the PLL is said to be in the free running state. Then, once the input frequency is applied, VCO starts to change and the phase lock loop is said to be in the capture mode. So, the PLL is in the capture mode when the input frequency is applied. And when the VCO frequency continues to change until it is equal to the input frequency, when both the frequencies, input and output frequencies, are equal, that is called as phase lock state. So, when the phase lock state, the loop tracks any changes in the input frequency through its repetitions. So, we will see what is phase detectors. In phase detectors, there are the input frequency and the VCO frequency is compared, and depending on whether the phase detector is an analog or a digital, it is known as the PLL is either known as an analog type or a digital type. So in analog, the phase detector, the input is applied to the mixer along with the output of VCO. The mixer generates sum and difference signals, that is, as we had discussed, Fin plus FO and Fin minus FO at its output, which is known as the error signal. Depending on the error voltage, PLL tries to log the applied frequency. So this type of detector is known as an analog detector. Then we next have the digital detector, wherein XOR gate is used. Now what is the property of an XOR gate? That if either of the input is high, the output is going to be high. So this is the truth table of XOR. So what happens is, whenever any of, that is, if Fin and FO, if either of them are high, the output is going to be high. You can see it here. This is 1, FO is 0, the output is 1. Again here you can see that Fin is 0, FO is 1, V is 1. So this is the digital phase detector. Then about the low pass filter, at the low pass filter we have two signals coming in, that is Fin plus FO and Fin minus FO, out of which the low pass filter passes only the low frequency signals, that is Fin minus FO, and which is given to the VCO. So this signal is known as VC, which is applied to the VCO. Now the signal VC shifts VCO frequency in direction to reduce the frequency difference, Fin minus FO. The difference is reduced so that both are equal. So this is known as capture range. VCO continues to change in frequency till the output frequency is exactly same as the input frequency. At this point, the PLL is said to be in the lock mode. So once it is in the lock mode, the output frequency FO is exactly equal to the input frequency. So now we will see the dynamic characteristics. In the dynamic characteristics, we see that the input frequency is, it will recapture the signal. Here you can see that PLL output VF, okay, and we have the lock range. The lock range is from F4 to F2, and it is proceeding towards the input signal. And the capture range is from F1 to F3. So what happens is, from F4 it is going to F1, then it is again moving towards FC, moving high towards F3, towards F2, and again to F3, moving downwards to F4, and so on. So the lock range and capture range are interlinked with each other. Here we have the lock in range. Once the PLL is locked, it can track the frequency and changes in the incoming signal. The range of frequencies over which PLL can maintain lock with its incoming signal is called the lock-in range. The capture range is the range of frequencies over which PLL can acquire lock with an input signal and is called as the capture range. There is pull-in time. The total time taken by the PLL to acquire lock is called as the pull-in time. So here we have the block diagram of PLL IC 565. We can see this diagram. Over here we can observe that the phase detector is there. Then when no input is given, that is pin number 2 and 3 are grounded. You can see that pin number 2 and 3, they are grounded. Pin number 2 and 3 are grounded. Then the free running frequency, we have FO. We will see what is the free running frequency, which is given by 1.2 upon 4 R1 C1 Hertz. Here R1 and C1 are the external resistor and capacitor, connected to pin number 8 and 9 respectively. C1 can be of any value, but R1 has to be the value of 2 kilo ohm to 20 kilo ohm. A capacitor C2, here we have C2, which is connected to pin number 7 and pin number 10. So it forms a first order low pass filter with an internal resistor of 3.6 kilo ohm. This is the low pass filter which is acting as a low pass filter. Then the VCO free running frequency FO is adjusted externally with R1C1 to be at the center of the input frequency range. The PLL 565 can lock and track an input signal over plus minus 60% bandwidth with respect to FO at the center frequency. The lock range FL is given by plus minus 8 FO upon V Hertz, where FO is the free running frequency, and the capture range is, we'll see what is it. The capture range is given by FC is equal to, so this is the free running frequency given by 1.2 upon 4 R1C1 Hertz. Then we have lock range given by plus minus 8 FO upon V, where FO is the free running frequency and V is plus V minus of minus V. Then we have the capture range which is given by FC, which is equal to plus minus FL upon 2 pi 3.6 K into C2, where C2 is expressed in farads. The lock range usually increases with an increase in the input voltage but decreases with an increase in supply voltage. So these are the three modes. So these are the references which I have referred. Ramakant Gaikwad I have used, and there is another book, that is Sullivan. So I hope you have understood this. Thank you.